Week 7, Exponential Growth and Decay. So last week we learned about exponential functions in the form y equals a times b to the x power, or sometimes that b was written as 1 plus or minus the r value. Well, what's different today is that instead of an x up as the exponent, we're going to be using a t, but that's just because t is standing for time. Now the a value is still going to be your initial value, or how much they start off with, and r is going to be your rate of growth or decay, and it always has to be written as a decimal. So for example number 1, it says, the original value of a painting is $9,000 and the value increases by 7% each year. So write an exponential growth function to model the situation. So they told us which kind of problem it is, so make sure that you've got the right formula. This one's growth with the plus sign, decay has the minus sign because it's decreasing. So now I just have to identify my a and my r values. Well, a is the original amount. They said that was $9,000. That's how much the painting started off with. And the value increased by 7% each year. So the rate that they told us was 7%. Now, we cannot actually use that 7% the way that it's written. You have to change it into a decimal. And one of the ways that you can do that is just to do 7 divided by 100. So 7 over 100 ends up giving us 0.07. And that's the number that we actually want to use for our r value. Now, I know several other teachers teach this different ways. Some use the decimal and the percentage, so this is how that would work. If you're starting off with 7%, okay, your percentage, your decimal's right here, okay? To change it to a decimal, I go 1, 2 to the left, put it there. So 1, 2 to the left, put it there. I have a placeholder, so it's 0.07. So you can use whichever way makes more sense to you. Now that I've got a and r, I can just plug them in. Y equals 9,000 times 1 plus the 0.07 to the t power. And the final step to simplifying this, I need to actually add those numbers together. So y equals 9,000 times 1.07 to the t power. And that is it. Example 2. The number of employees at a certain company is 1,440. So that is our beginning amount. That would be our a value. And they said it's growing. So once again, we are dealing with exponential growth at a rate of 1.5%. So my r value is 1.5%. Now, a common mistake is some people see the decimal, so they think that this is already in the format where they can use it. No. If they give you that percentage sign, that means that you need to take that 1.5 and either move the percentage sign decimal over, or you can do the 1.5 divided by 100. And that'll show you that the rate that we need is actually 0.015. So I'm going to plug that into my formula. Y equals 1,440 times 1 plus the 0.015 and raised to the t power. So the very last thing that you need to do is actually add those numbers together inside the parentheses. That's 1,440 times 1.015 to the t power. And we're going to leave it just like that. All right, number 3. A new car is worth $25,000 and its value depreciates 15% each year. Okay, if you don't know what that word means, it means that it is decreasing. And you can always look it up if you come across some new vocabulary. So since we are doing exponential decay, this time we have to have 1 minus the rate inside our parentheses. Everything else is basically the same. So our starting value was $25,000 because that's how much the car was worth originally. And the rate that it's depreciating at is 15%. So before I can do anything with that, I'm going to do 15 divided by 100, which is 0.15. So this is the number that I'm going to use in place of r. So y equals 25,000 times 1 minus the 0.15 to the t power. And the last thing you need to do is actually simplify those two numbers together inside your parentheses. And I highly recommend that you double check yourself and type it in, hit enter. That is 0.85. So y is equal to 25,000 times 0.85 to the t power. And that's it. Last problem, number 4. The deer population of a game preserve is shrinking by 2.5% per year. So the original population was 1,850. So that would be my A value right there. So we're writing exponential decay, which means it's 1 minus the rate. So let's go ahead and find out what that rate is. It started as 2.5%, but remember, we still have to take that 2.5 and divide it by 100. So if you do, that's 0.025. So now I can plug this into my formula. Y equals 1,850 times 1 minus 0.02. And now I just need to let this simplify inside my parentheses. So when I type that in, I got 0.975. So y is equal to 1,850 times 0.975 to the t power. And that's it.